So Intel Raptor Lake is finally here, and I managed to get my hands on the EVGA Z790 DARK KIngPin motherboard with the brand new Intel 13900K CPU. Even though as EVGA has kinda officially left the GPU market, at least for now, they are still present on the motherboard scene, and they will have some amazing motherboard models coming out of the retail market for these new generations. So obviously the DARK KIngPin will be their highest end option for the brand new 13th gen CPUs and the Intel Z790 platform. So the overall layout is still pretty much the same as on the previous DARK and DARK KIngPin motherboards. So we still have the rotated socket over here. We have very rock solid VRM both for the CPU and for the memory. So you should be able to achieve pretty much top of the line performance both on the CPU and on the memory on various different cooling methods. We have PCI Express layout for up to 2 graphics cards in SLI or Crossfire X, and these are Gen 5 PCI Express slots, by the way. We still have third-party SATA controller over here, so this motherboard does support a huge variety of different operating systems, even the ones that are older than Windows 7. Those are pretty much the main features. The only thing that I don't really like about this design is this bottom PCI Express slot over here, which is connected directly to the PCH or the chipset. If you want to use a full-length device over here, like a graphics card for testing purposes, this battery over here will get in the way if you want to install a full-length device onto this slot over here. So if you want to use a full-length device, you need to remove the battery first. These motherboards generally work even without any battery at all, but you will lose all of the settings once you turn off the power from your rig. So I just received this combination, so I thought about testing this whole platform together with you guys, like see what kind of performance does it have, how does it score in different tests, how can it overclock on good water cooling, and I also have the brand new and highly anticipated A-die memory by SK Hynix over here. So huge thanks to Sense from our team for sending me those sticks. I have 2 of them, and those sticks are known to be able to go well above DDR5 8000 megatransfers per second, all on air cooling. So air cooling on both the CPU and on the memory. So we should be able to see DDR5 frequencies up to like maybe 8500, maybe even 8600 and beyond. It of course depends on your IMC quality and how good are the sticks themselves, but we should be able to see pretty intense DDR5 frequencies on this new platform from Intel. So anyways, I will set up this motherboard and CPU combination to my bench table. Let's see how does it actually look like inside the BIOS and inside the operating system, and let's hope for the best. Let's see how interesting performance figures and overclocking results we can achieve. And okay, that's the rig itself. So the motherboard is now placed on top of my bench table, custom water cooling on the CPU, and yes, those memories, they do stand out from the rest of the system as they have green colored PCB. They are pretty much like bulk or no name A-die DDR5 memories, but they are supposed to be good. And then just Galax 710 GT just to display the monitor signal with the capture card, and Superflower LeadX 8 pack 2000 watt power supply. But without further ado, let's get going and let's see how this actually performs. Now before we start doing any overclocking, let's check like what kind of performance this brand new platform has at start in various different tests of which we are mostly interested in. So let's open up Benchmade. So you should use Benchmade if you want to do like some kind of quick testing. If you are doing overclocking, for example, this does include all of the like many of the known tests, like different versions of Cinebench, etc. So I think nowadays most of you are using either Cinebench R20 or R23. I think R20 is still like more like common than R23, but many people do already run Cinebench R23. So let's open up CPU-Z, and I like to use core temp for measuring the temperatures of the individual cores. So this CPU has a stock frequency of 5.5 GHz it seems, and it can boost even higher when only some of the cores are being used. And it seems that the stock speed for the add-on cores is at 4.3, so that's definitely a bit higher than on the previous generation. But yeah, let's fire up Cinebench R20, and this is everything at like stock pretty much. So temperatures are like in high 60s, and yeah, 4.6 on the cache, 5600 cache 46 on the memory. And we have 5.5 and 4.3 on the individual cores, and the stock performance was 14,053 points. Not sure if this V-core value is correct, so 1.3 something, but temperatures are high 50s or early 60s for the add-ons, and P-cores ranging from 63 to like 76. So pretty okay, I guess. So the score was 37,001 points. When it comes to Geekbench, many people or most still favor the older versions of the Geekbench 3, and that's the same story for me. I don't run the newer versions that much, so Geekbench 4 and 5. Let's run the Geekbench 3, and then last test after this one will be AIDA 64, the cache and memory test, the first line pretty much. Okay, so the stock performance was 106,943 points, and the stock memory performance on the multi-core was 9,337. So let's save that one down as well, and the last test will be AIDA 64, but as far as I know, it actually takes quite a long time on this newest generation. Or it could be because of the newer versions of the test, but don't know, but it does take some time. So AIDA 64, start memory tests only, and it will take some time to complete the memory section of the test. Okay, so close to 86 gigs on the read, 77.67 on the write, and 77.293 on the copy speed. And latency was very slow, so 79.5. So we can definitely get these three much higher and much lower value on the latency as well. So that's our starting point pretty much. Okay, so this is how the BIOS of the Z790 Dark KINPIN motherboard looks like. So it's pretty much the same thing as all of the previous Dark and Dark KINPIN motherboards this far. Now, the first thing what you have to do when you start to overclock this brand new Intel Raptor Lake platform is to go to the CPU configuration part of the BIOS, and you need to disable the enhanced TVB or the thermal velocity boost setting. If you leave this at auto or enabled, your CPU will throttle very badly when you run the CPU at higher frequencies than the stock frequency of 5.5 GHz. So some of the individual cores will start dropping like to 4.6 GHz or 5.3 GHz. The lowest frequency I saw on some individual cores was as low as 800 MHz or 1.6 GHz. So exactly as it suggests on the right side of this screen over here, it is required to be disabled for supporting overclocking at frequencies higher than the default max turbo frequency. So I just changed it to disabled, and that's pretty much it. Now the first thing that caught my eye is the very low VID voltage of this CPU. So it's way below 0.9 volts, so that's extremely low stock voltage if you ask me. Now, as the stock frequency was 5.5 GHz for the CPU on the P cores, and there's definitely not that much headroom remaining, especially if you use a more simple cooling solution, you have to proceed with extreme caution. I think at least 5.7 should be alright for this CPU, so I will just set this setting to the CPU multiplier control to manual ratio limit. So I will overclock all of the individual cores to same frequency, but of course you could fine-tune a little bit and use the manual per core function to get like individual cores, like 1 or 2 cores up to 6 GHz. So 5.7 on the P cores, and this way of overclocking is a lot faster as well. Ring is the cache. The stock frequency on the cache was 4.6, and I think at least like 4.9 to 5 should be alright. Now there's negative offset yet again for AVX2 and AVX512. And you have to utilize these ratio offsets to be able to remain stable in various different workloads. So the AVX based workloads, they will draw a lot more heat compared to like more common workloads. Yes, there is still AVX 512 negative offset, but we can be absolutely certain pretty much that this time around we will not see unofficial support for these CPUs. I'm sure Intel has learned their lesson from the Alder Lake release, and we will not see like unofficial way of getting AVX 512 to work. So that's at least something what I think. So for quick testing now, I will leave this setting at 0, but you should use a negative offset of 2 or 3 at least, if you ask me. So if you set 5.7 for non-AVX based workloads, and if you use a setting of 3, it will drop the frequency to 5.4 GHz when the CPU starts utilizing the AVX instruction sets. So the stock frequency for the add-on cores was 4.3. I think at least 4.5 to 4.6 should be somewhat stable, and I will select the add-on voltage to override mode as well, and 1.3 volts. On the Alder Lake platform, a good voltage on the add-on cores was somewhere around like 1.27 or just a tiny bit under 1.3. But going above 1.3 didn't usually help, or at least on the previous generation. Now, base clock is at 100. The BCLK patch will be for possible non-K CPU overclocking. It's not really needed with the i9 variant or with the K CPUs anyways. Extreme voltage mode you need to enable if you want to select higher memory voltage than 1.435 on your memory. As I'm using these brand new SK Hynix A-die memories, many of the PMICs cannot go above that stock limit of 1.435 on many of these motherboards, but these particular sticks can actually go much higher than 1.435, even up to like 1.8, something like this. And there's a safety feature in this motherboard's BIOS that you need to enable the extreme voltage mode if you want to go above 1.435 on the memory. If you ask me, a good range for like daily stable overclocking is still between like 1.435 and 1.5. I think something like 1.48 is still relatively safe, like for daily use, but that's only like my feeling only. That's not based on any like facts. So I don't know what is the real like maximum safe value for daily use. We could see like kits that had like around 1.4 already as the stock voltage. So I'm sure at least like 1.435 is definitely safe for daily use if you have adequate airflow over the socket area and the memory sticks. Then FLL override can be left at mode 1, and I will use a fixed V core at 1.35 volts, and that's pretty much the same value what it already used at stock. When I checked the load line calibration option, the best value is -75% min droop. So with -75% setting, and this is the same thing as on the Alder Lake, so Z690, this has the best value between idle and load. So -75%, it's 1.35 idle and 1.35 under load. When I checked -50%, it would droop around 35 millivolts under load. So 1.35 idle and 1.315 under load. Switching frequency can be somewhere between 600 and 800 kilohertz. I still wonder why they include options above 800 kilohertz if it only starts to decrease the overall stability. Very good question mark. This was the same thing on Z690 or Alder Lake CPUs. The real IMC voltage is the CPU VDDQ this time around. So the system agent you can actually often just leave at auto or set manually somewhere like between like 1.3 to 1.45. I usually leave it at auto, and I set the VDDQ to the sweet spot range for my own testing, which has been between like 1.23 and 1.35. Usually 1.26 was always the best value for me on every single Alder Lake CPU. You can go even up to like 1.53, even on air cooling or water cooling on this voltage, but for me it never gave any like real advantage on the memory stability. But this is something you have to test out yourself. Input voltage either auto, so the stock value of 1.8, or you can do like a minor increase on this voltage up to like 1.9, but that's something you have to test out yourself as well. So that's pretty much it for the CPU part. And memory, as I do know this kit, like roughly I will set it at DDR5 8000 with 1.48 volts and 36, 48, 48, 42 and command rate 2. So that's pretty much it. That's what I will use for starters, and let's see, is this actually stable inside the operating system, and what kind of performance increase can we see in those different tests, what we already briefly checked. Okay, so we just got to the operating system once again. Let's open up CPU-Z and let's start with Cinebench R20. We can do like initial tests now first, see what's stable, where do we max out on those different parameters, so the P cores, the atom cores, the cache, etc. And then we can run all of those tests at the maximum frequency. So Cinebench R20 first, see where the temperatures actually get up to this time around. So already 80, warmest core, no throttling whatsoever, so all of the cores are at 5.7, all of the atom cores are at 4.5, and the maximum core temperature already at 83 degrees Celsius. Atom cores between like 60 degrees and like around 70. It could be some efficiency thing, but we didn't really increase the performance like at all, which is quite weird. So 14,191, pretty interesting. So we didn't really increase at all. Let's try a bit more. So let's open up Elite X1. Let's put the P cores to 5.8, like so. And you can use, if you use Dark Kingpin, you can use the Elite X1 for more accurate voltage measurement to check the different load line calibration settings. So if we fire this up, we have 1.356 at idle and 1.35 under load. So no big like voltage drop whatsoever. So let's close it. Temperatures should remain around the same values, as voltage has a lot bigger impact on temperatures compared to the actual clock speeds. So 15,176, so maybe the previous run was just bad, like bad efficiency, whatever. I'm sure 5.9 will fail, so that's definitely not going to pass. 5.8 is already pretty high value if you ask me. So 5.9, but I'm sure this will crash. Yep, so it crashed already from the get-go. I'll go back to Elite X1 and that's the maximum for the P cores, so between 5.8 and 5.9. Of course, we could fine-tune even more if we use the per core function. So I'll go back to 5.8. Let's increase the cache to 50 from 4.9 and atom cores to 4.6. Voltage is still the same. Now, temperatures still roughly the same. 4.6 atom, 5 GHz cache, 5.8 on the P cores. So 15,666, so the atom cores do have quite a big impact on your overall performance when all of the cores are being used. Let's go back to Elite X1 and let's try to push for 4.7 on the atom cores. But that should be the max, I think, for... I really doubt we would see like 4.8 on the atom cores. Cache might still have some headroom remaining. So 4.7 on the atom. So almost. So it hang, but it's definitely on the edge. So I think I could be able to pass this, I'm pretty sure. Okay, so very interesting. So when I rose the atom voltage to 1.32 from the value of 1.3, it didn't really help at all. But now when I put it back down to 1.27, it passed. So at 50,893 points. I actually passed it before, like one attempt earlier, and I got a score of just a tiny bit over 16,000. So it seems that the overall voltage range is roughly the same as on the previous Alder Lake generation. So 1.27, very good value for the atom voltage for like daily use, so on air and water cooling. So 41,573 points. So pretty interesting. So it's very on the edge, so probably better option just to go back to 4.6 for daily use, like I said. So let's save this and Now we'll run Geekbench 3. 119,571. And memory score was at 13,567. So pretty good, I guess. So like 13,000 point increase over the stock performance, but most of that is actually from the memory. So yes, these CPUs, they don't have that much headroom for overclocking as they are tuned to the max already at the factory. And now the last one will be AIDA 64. Okay, so the read speed 126.8, writes 114.93, and copy 113.11, and latency at 53.5. Pretty okay numbers if you ask me. But yeah, so that is definitely the maximum when it comes to like the CPU overclocking part. Now it's more about finding the sweet spot, like memory configuration. Like you need to test the entire capacity once again with something like HCI Memtest. And now of course we could try like how does this remain stable at various clock speeds in Pro 95, and yes, you need to utilize the negative offsets. So it's even a question mark that could 5.8 be stable in non-AVX Pro 95. So that's something you have to test out yourself. Let's do a very quick test in Pro 95. Just see the temperatures. I have set the negative offset of 2 for AVX1 and AVX2, so it should drop to 5.6 for those workloads. So now let's disable the AVXs, but it still might just fly through the roof on the temperatures over here. But the temperatures don't really look that much worse compared to R20, R23 at first glance. So let's stop it, because I don't have any heatsink on the VRM. I don't want to overly stress the CPU in Pro 95 for now. So what I want to see is just quickly the AVX temperature. I dropped the atom cores to 4.6 but 1.27 volts. So like what's the temperature with AVX1? Torture test, small FFT and AVX1, and does the negative offset of 2 affect the atom cores as well? Yeah, it doesn't affect the atom cores, and yeah, those temperatures are freaking high. So 96 degrees highest on the 6th core, 94 over here. So definitely warm temperatures, and AVX2 definitely will be hitting 100 degrees. So this is definitely a problem, because we would like to have lower voltage for those lower frequencies with the AVXs. So this is definitely a hard thing. Actually, I just want to see the power figure very quickly with AVX1. 468 watts. Yeah, it's definitely not an easy task to cool 450 to 500 watts on the CPU. I'm quite scared to even fire up the AVX2. Let's go to 5.6. I'll go to 4.5, and I'll drop the V core to 1.3. Now I don't remember, does the AVX negative offset work when you change like clocks inside the operating system? Torture test, AVX1, what's the maximum? Yeah, it doesn't work when you change the clocks inside the operating system. So now we will have 5.6 for AVX2 as well. But the temperatures are now much easier, like 89 degrees max so far, but of course it will go higher over time. So just for safety, I'll drop the frequency to 5.5. And I want to see the power load with AVX2. Yeah, it's in the same range. So 97 degrees, and yeah, like over 80, etc. So this is definitely a problem for like daily use. So if you want to use this kind of loads, you need to have very strong cooling, etc. But of course, no like daily software will have as high load on the CPU like something like Pro 95. So you shouldn't be too worried about this, but that's something you have to take into account. So yeah, so that's pretty much it. So yeah, 5.8-ish max on the P cores, non-AVX, and maybe AVX like 5.5 to 5.6. Pretty high values if you ask me. And up to 4.6 to 4.7 on the add-ons, and 4.9 to 5 plus on the cache. So now the only thing remaining is the memory. And okay, I couldn't raise the memory frequency any higher, so I tried like 8200 for a few times, but it often wouldn't even post and boot successfully, and if it did, it was very unstable. But what I could do was that I could actually tighten many of the timings, so especially the third timings, they are set to very good levels right now. And also the cache latency, I managed to drop from 36 to 35. 34 doesn't want to post, it stuck at debug code of 31 for some reason, so it doesn't want to post. I tried TRCD and TRP at 47 and 47, but it fails after some rounds in the HCI Memtest. So the current configuration, the best one that I could pass, is 35, 48, 48, 42 and command rate 2. So pretty good, I guess. It could also be IMC limit, that what prevents me from going any higher, like with full stability, as 8000 plus is definitely very high for these memory controllers, at least on ambient based cooling. So the settings, so 35, 48, 48, 42, 8 and 6. I think 4 active window could come even a bit lower, like to 16. TRFC, I think I could go a bit under 400, like 380 maybe. The most important one, so the refresh interval is set to the max. And these are then the third timing, so they are set to pretty okay values, I think. Only these two could maybe go a bit lower, but that's pretty much it, I guess. So pretty good values overall. So read is close to 128 gigs, write 124.26, and copy 122.41, and latency 52.8 nanoseconds. So latency I would have liked to see like under 50 nanoseconds, but it doesn't want to really go there. I don't know what would be the key to get the latency under 50 nanoseconds, but I think these numbers should be alright if you ask me. But yeah, so that's pretty much it. These are my first impressions about this whole platform. So the Intel Raptor Lake is definitely a very interesting release from overclocking perspective. The frequencies are extremely high. So we can reach extremely high frequencies, both on ambient based cooling and also on sub-zero cooling. So we have very high frequencies already out of the box. I think the very best CPUs could do like 5.9 in Cinebench with all cores on water cooling, I mean. So I'm pretty sure we won't see 6 GHz Cinebench on water cooling. I'm not fully sure, but I think it would be too high. So very high frequencies, and the interesting part is about sub-zero cooling. So we have seen over 8 GHz doable even in benchmarks. So people can run, let's say, simple 3D at above 8 GHz, and the highest validation at the time of making this video is by Elmore from Sweden at 8.8 GHz. But if you watch his video, the validations are kind of hot topic if you ask me. So he was running 8 cores and 8 threads, so add-on cores as well as hyperthreading disabled. But if you watch the video very carefully, you can see that only one of those cores is being used. So only that single core is being validated at that 8.8 GHz frequency, and the rest of those cores are kept at much lower frequency. So even though there are multiple cores enabled, only one of them is being used for the validation. So that's one of the main reasons why I don't like about these validations. You can have 8+16/32 visible on CPU-Z, yet only one of those cores is actually used for the validation. So that's one of the main reasons why I'm not a big fan of validations. So real performance tests are better if you ask me. But nonetheless, very interesting launch. So let me know what you think. What do you think about this release and this platform in general? What would you like to see about this platform on my channel? I think I already covered the basics of overclocking this 13900K as well as those A-die based memories quite well. Just let me know what you think in the comments section down below, and give me a thumbs up and subscribe to my channel. Maybe check out my Patreon page as well if you want to support my work, and if you want to join my Patreon Discord channel. But other than that, thanks for watching one of my videos once again, and I will see you on the next one.